Hello everyone, myself Sahil. I am a research scientist at Google Research and I will be presenting my paper titled Data-Centric Debugging Mitigating Model Failures via Targeted Image Retrieval. This work was carried out with my collaborators at the University of Maryland, Atoosa Chegini, Mazda Moayeri, and Professor Soheil Feizi. Consider the following problem setup. We have a trained neural network which achieves high performance on some validation set, but poor performance on another validation set. Our goal is to improve model performance on the second validation set while maintaining performance on the first validation set. We tackle this problem as follows. We divide the low performing set into two disjoint subsets. We call the first set the debug seed set and the second set the debug held out set. Using the debug seed set, we find images from the web that are visually similar to the images in the debug seed set. Next, we filter the set of images to remove images that are very similar to the test set images. The resulting dataset is what we call the debug-train set. We train a model on the debug-train set and evaluate model performance on the debug-held-out set. Next, we discuss the implementation details. We use 160 classes of ImageNet v2 to construct the debug seed and debug held out set. We use Flickr search for searching for candidate images per class, and we use DINO VIT S8 embeddings for finding visually similar images. Next, we discuss the experimental results. We compare the performance across three datasets, namely ImageNet, ImageNet v2 debug seed subset, and ImageNet v2 debug held out subset. Here are the results. We experiment with different training methods, namely using unsupervised learning on some large weakly labeled dataset with more than 100 million images, adding the complete noisily labeled dataset obtained using Flickr search, and adding a random subset of the noisily labeled dataset again obtained using the same Flickr search. And our method here, DCD DINO VIT S8, denotes similarity matching using the DINO VIT S8 model. On the debug held out set, we observe significant improvements over the baselines, and we observe that the performance on ImageNet is maintained. In summary, we introduce a framework for mitigating model failures via data-centric debugging. We show that DINO VIT S8 models are superior for similarity matching for debugging purposes. We observe significant, that is, greater than 5% accuracy improvements using our proposed approach. Code is available on GitHub. Please feel free to reach out to me via email if you have any questions. Thank you.